Isaac Newton's legendary second law of motion states that F net is equal to ma. Is this true? Let's talk about it. If I had an apple of mass 2m and an apple of mass 1m, and I dropped them both from the same height at the same time, intuition might tell you that the mass of 2m will drop quicker because it's got the biggest net force. Fg is equal to 2mg. Whereas for mass 1m, Fg is solely equal to 1mg. So is that the end of the story? The apple with mass 2m will drop quicker because it's got the biggest net force? No, because of inertia. Newton's first law talks about how inertia resists the object's motion depending on how big it is. So if we look at this through the equations, ma, which is F net, should equal mg. For the first equation, the m is 2m, so 2ma should equal 2mg. As we see, the 2m's cancel out, and the acceleration is simply gravity. For the mass of 1m, F net equals 1ma, which is equal to 1mg. The masses once again cancel, and acceleration should just equal g. What this means is that despite the fact that mass of 2m has more force of gravity acting on it, and therefore a higher net force, the inertia of that 2m also plays a role in resisting the acceleration, and therefore the acceleration of both the mass 2m and m are the same, and they reach the ground at the same time. That's why I think a more accurate way of writing your F net equation from Newton is A is equal to F net over m. This properly displays the relationship between how big an F net is and how massive it is, as the more F net something has, the more acceleration it will have, but if it's more massive, it'll have more inertia, and therefore acceleration will decrease. In the case of the apple, that increase in mass was perfectly proportional, which led to acceleration always equaling gravity. So yes, Isaac Newton was right in this equation, but a more indicative way of explaining the relationship of A between F net and m would be this equation.